Algebraic fractions 13, problem solving. Let's have a look at some questions that involve problem solving with algebraic fractions. Here's a good one. Work out the value of y. So we've been given a rectangle, we've been told its area, and we've been given a length and the width. Well, you should know that area of a rectangle is equal to length multiplied by width. So we can create an equation out of this information. We can say y minus 3 over 2 multiplied by 5 over 3y plus 8 is equal to 10 over 29. Well, this is an equation that we can now solve. When multiplying algebraic fractions or any fraction, we simply multiply the numerators and the denominators together. So this can be rewritten to 5 brackets y minus 3 over 2 brackets 3y plus 8. Well, I would like you to expand the numerator and the denominator. Pause the video now. Well done if you got 5y minus 15 as the numerator and 6y plus 16 as the denominator. So here is the equation that we want to solve. Now we have two fractions that are equal to each other. We can use the concept of cross multiplication. This can be rewritten. So we can say 29 brackets 5y minus 15 is equal to 10 brackets 6y plus 16. Okay, what I'd like you to do now then is to expand both sides, simplify, and then solve the equation. So pause the video now and work out the value of y. Well done if you got y being equal to 7. So when we expanded, you should have got 145y minus 435 is equal to 60y plus 160. Now we can balance these equations. I'm going to subtract 60y from both sides and add 435 to both sides, leaving me with 85y equals 595. So y is equal to 595 divided by 85. That's quite a difficult division to do without a calculator. The way I made it easier, I divided top and bottom by 5, leaving me 119 over 17. And 17 goes into 119 7 times. So y is equal to 7. Let's try one more question. Solve x plus 1 to x minus 2 equals 17 plus x to x plus 8. Now this looks like a very complicated question as you have two algebraic ratios that are equal to each other. Well, let's look at normal ratios and see what the relationship is. Let's take the ratio 1 to 5. That's the same as a ratio of 2 to 10. We can say they're equal to each other. Well, look, 1 over 5, 1/5, is equal to 2 over 10, because 2 over 10 simplifies down to 1/5 as well. So the rule is, if we have ratios A to B equal C to D, we can rewrite this as A over B equals C over D. That really helps when solving this. So I'm going to rewrite this as x plus 1 over x minus 2 is equal to 17 plus x over x plus 8. Well, now we can use the concept of cross multiplication. This can be rewritten to x plus 1, x plus 8 equals x minus 2 and 17 plus x. Now at this point, I want you to expand both sides of this equation. Once you've done that, hopefully you'll realise it's quite easy to solve this problem. You can simply balance both sides and you'll get the value of x. So pause the video now. Very well done if you got x was equal to 7. Here's what you should have got. The left-hand side, when you expand that, you get x squared plus 9x plus 8. On the right-hand side, x squared plus 15x take away 34. Well, I can cancel out these x squareds, take them away from both sides. I can then subtract 9x from both sides. That leaves us with 8 equals 6x, subtract 34. Well, then I add 34 to both sides, so 6x is equal to 42, x is equal to 7. The key here, whenever you see two equivalent ratios, remember that you can write them as fractions that are equal to each other. It makes these problems much easier to solve.